In this video, I'm going to review the use of formulas to find the area of triangles and four-sided figures. Before we get to some practice problems, I want to talk about a key concept to area formulas. That is the concept of a base of the object and a height. So let's look at three different shapes here. Here we have a triangle. So our base is down here at the bottom of this triangle. We have a perpendicular dotted line here that's measuring the height of this triangle, the distance from the base to the very top. And those are the two dimensions that we will need in order to find the area of a triangle. Likewise, here is a trapezoid. A trapezoid actually has two bases. There's a base down here, there's a base up here, and in between we have the height, which is connecting those two bases, again, at a right angle. The height is the distance between those two bases in the trapezoid. And finally, we have a parallelogram. Now, a parallelogram only has one base. We're labeling this side as the base. We have, again, our dotted line, as that is measuring the distance between this base and the opposite side. With that in mind, I want to make it clear that the base is not always at the bottom. Most of the time it will be at the bottom, but sometimes you might have a figure like this. This is the base, and this is the distance between the parallel sides, which is the height. But in this case, the height is side to side, not up and down. So that's okay. That is still the height. All right, let's take a look at a few examples. What is the area of a triangle? First of all, we need the formula, and all of these formulas are on the GED formula sheet. So in this case, the area of a triangle is area equals 1/2 times the base times the height. Here's our example triangle. So we can see that this dotted line, that must be our height of 6.5 centimeters, and our base is down here, 11.6 centimeters. So we just have to put this together. Area equals 1/2 times our base, 11.6, times our height of 6.5. Now, you should be doing these problems in your calculator. I like to replace 1/2 with the decimal 0.5 because that makes it a little bit easier to enter into the calculator. So we end up with 0.5 times 11.6 times 6.5. And I hope you're doing this along with me. You should get 37.7. And that is centimeters squared. That's how we would note that. What is the area of the rectangle? The formula for an area of a rectangle is very simple. You're probably familiar with this. It's just the length times the width, not too complicated. Here's an example. And we recognize that this is a rectangle. All of these are right angles. Must be a rectangle. And we just multiply those two dimensions together. And we don't have to worry about which one's the length and which one's the width. That's not important. We're just multiplying two numbers together. 20.4 times 9.5, which is 193.8. And our units are yards. So that is going to be yards squared or square yards. All right, let's move on to a parallelogram. The formula for the area of a parallelogram is very simple. The area equals the base times the height. Looking at an example. Now, one thing that problems might try to do is trick you into using extra dimensions. We only need a base and a height to calculate our area. This is a base, and this is our height, this one that's going at a right angle to it. H is going to be 10.2. Our base is going to be 16.6, which means we don't need the length of that side. That's not necessary for us to calculate the area. Area equals our base of 16.6 times our height of 10.2 Put that in your calculator, and you should get the answer of 169.32. Okay, the last new shape is what is the area of a trapezoid? This may look like the most complicated formula, and it kind of is, but it's not too bad. Area equals 1/2 the sum of base 1 and base 2. We already talked about the fact that there's two bases, and then we're going to multiply that by the height. Let's take a look at our example. We got a lot of numbers here. Some of them we don't need. This is our base 1, and it doesn't matter which is base 1 and base 2 because we're just going to add them together. So we could say that's base 2, and this distance between the two is our height, which means we're not going to use that, and we're not going to use that. We just need these three numbers, base 1, base 2, and the height. So let's put it together. Area equals, and I'm immediately going to substitute 0.5 for 1/2 because I think that's easier. And then I'm going to add my two bases, 15.6 plus 11.4. And I encourage you to put this in the calculator exactly as I'm writing it, because that will help make sure that you get the right answer. When we plug that in, we should get an answer of exactly 135, and our units are feet, so we should be aware that this is square feet. So sometimes it will be written that way, SQFT. Other cases, it might be written like this, feet, and then the squared symbol. In this video, we're going to review various methods you can use to find the missing angles in triangles and four-sided shapes. Two very important facts that we need to keep in mind as we solve these problems. The first is that the sum of all three angles in a triangle will always equal 180 degrees. That means if we know two of the angles, we can find the third through subtraction. In a similar fashion, the sum of all four angles in a four-sided figure, these are all four-sided figures, a square, a rectangle, a parallelogram, a trapezoid. The sum of each of those angles adds up to 360 degrees. So keeping those in mind, let's move forward and do a few examples. In this problem, we're asked, what is the measure of angle A? So you can see down below, we have a triangle. It's labeled A, B, C, and we know two of the angles. The key fact that we need to use to solve this problem is that the angles of a triangle total 180 degrees. That means we can start out with 180 and subtract the two angles that we know. Subtract 60. We subtract 80, that leaves us with 40 degrees. This angle must be 40 degrees. And we could check that by adding these all up and making sure that we get 180, which we do. Let's move on to a similar kind of problem with a four-sided figure. What is the measure of angle C? So when they refer to angle C, we're talking about this corner, and we can see that we know angle B is 81. We know angle D is 77. What about angle A? Another fact that we need to take into account here. The first fact that we're going to use is that four-sided figures, the angles total 360 degrees. But a square in the corner means that the angle is 90 degrees. It's sort of a shortcut notation so that we can communicate that that's 90 degrees. So now you can see that we know three of the four angles. So we can do the same thing we did with the triangle. We start out with 360 and we start subtracting 81 and 90. It doesn't matter which order we subtract these in. And we get 112 degrees. are left over. That means that this must be 112, and there is our answer, B. All right, this one's a little bit different. Find angles A, B, and C. What facts do we need to solve this one? Once again, we want to keep in mind that angles total 180 degrees in a triangle. But we also need to know that when three sides of a triangle are equal, that makes something called an equilateral triangle. It means that the angles are also equal. All of these angles are the same. This angle and this angle and this angle are equal. And if they all have to be equal and they all have to add up to 180, we can just divide 180 by 3. And those must be 60-degree angles. And that's always true of an equilateral triangle, that the angles will be 60 degrees. It doesn't matter what size it is. Move on to the next question. If the measure of angle B is 65 degrees, what is the measure of angle C? The key facts that we need, of course, the first one, angles in a triangle must total 180 degrees. But the second one is really important. When there's two equal sides to a triangle, this is called an isosceles triangle. It means that there are two equal angles. And it's going to be the angles that look like they should be equal. It's this angle and this angle in this triangle. We can see that angle A is different. So going back to the question that was asked, if the measure of angle B is 65 degrees, what's the measure of angle C? Well, it's also 65 degrees. Now let's imagine that this question also asked us for the angle A. We could find angle A because we could say now that, well, the total is 180. I'm going to subtract angle B, which is 65. I'm going to subtract angle C, which is also 65. And that's going to leave me with 30 degrees. So with an isosceles triangle, if you're given one of the angles, you can figure out the other two angles because you know that two of the angles are equal. Next question. The opposite sides of the shape below are parallel and angle A is 70 degrees. What is the measure of angle B? Once again, our letters are referring to the corners. The key facts that we're going to use to solve this: four-sided figures, the angles total 360 degrees. So we know that the sum of A, B, C, and D angles will be 360. Now, with a parallelogram, and that's what this shape is, it's a pushed over rectangle where the angles are not 90 degrees in the corners. The opposite angles of a parallelogram are the same, are equal. So that means that if A is 70 degrees, then C is 70 degrees. And we're trying to find angles B and D, or actually just angle B. But once we know angle B, we will know angle D. So this is a little bit trickier. We need to take 2 steps to solve this problem. We're going to start with 360 and subtract 70 and subtract another 70, because that's going to give us the angles that are left over, or the degrees that are left over between B and D. That's 220 degrees. Now, if we know that B and D are equal and that they total 220 degrees, then we just have to divide by 2. 220 divided by 2 is 110 degrees. 110, and angle D is also 110, and we could add these all up and make sure that they equal 360, and they do. And here is our answer over here, B, 110. In this video, I'm going to review how to find the missing side of a right triangle using the Pythagorean theorem, or this relationship that's shown at the bottom of the screen. Let's take another look at that. A squared plus B squared equals C squared. Sometimes it's written the other way with C squared first, but that doesn't matter. It's the same relationship. And let's look at that relationship for this triangle that's shown. We have sides of 3 and 4 that are at a right angle to each other. We call those sides the legs. They're the shorter sides of the triangle. The longest side of the triangle we call C. It's called the hypotenuse, and it is opposite that right angle. So A and B, it's not important which ones we label those as. They're just the short sides, but it is important that we label C as the long side. So let's square 3. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. So A squared is 16. B squared is 9. And C squared is 25. So look at how that holds true for this triangle. 16 plus 9 is 25. So 25 equals 25. And that's true. So that's interesting, but it doesn't quite help us solve problems yet. Let's look at an instance where we can try to find this long side of this triangle using that relationship. So let me square these short sides again. 6 times 6 is 36. 8 times 8 is 64. So let me label this as A and this as B. Again, it doesn't matter. It's just kind of helpful to keep track of. So A squared is 64 plus B squared is 36. I strongly encourage you to try to follow along with your calculator here. You're going to get more out of it if you can do that. If you don't have your calculator, pause the video and go get it. So now let's add 64 and 36 to get 100. So 100 is equal to C squared. But we're not interested in what C squared is. We want to know what C is. We can find C by taking the square root of both sides. By taking the square root of C squared, we just get C. By taking the square root of 100, we get the number 10. That's the answer that we were looking for. This long side must have a length of 10. But we needed to take the square root of both sides to find that. Let's take a look at an example where we're trying to find one of the shorter sides or one of the legs. We could start out by squaring those other numbers because we know that we're going to have to do that. 9 squared, or 9 times 9, is 81. And 15 squared, you can do this in your calculator. 15 times 15, or 15 squared, is 225. So let's put that over here. B squared is 81. C squared is 225. And we want to know what A is. So we have to do a little bit of algebra here. Let's subtract 81 from both sides. This is kind of a two-step equation here. That's going to cancel this out. And it's going to leave us with A squared is equal to 225 minus 81, 144. Now, we don't want to know A squared. We want to know A. So we need to do that thing where we take the square root of both sides. A is equal to the square root of 144, which is 12. Our missing side had a length of 12. So once you've done some of this, you start to realize that you need to take the square root at the end. So why not take a little bit of a shortcut and memorize this formula? When we're trying to find the long side, we are going to take the square root of the sum of the square of the other two sides. So we are going to square 15, and we're going to square 20, and we're going to add those up and take the square root of it. For the short side, likewise, we could say that A is equal to the long side squared minus the short side that we know. So in this case, it's going to be 50 squared minus 40 squared. And we're going to take the square root of that. In this video, I'm going to review using the formulas for the area and circumference of circles. These are formulas that are both on your GED formula sheet. These formulas involve the number pi. So you've probably seen the symbol pi. It's just a number. And we can use the approximation of 3.14. We can substitute that number for the symbol pi in the equation if we like. Or we can use the pi button on the calculator, and that gives us a much more exact version of pi. But both methods should give you the right answer, so I wouldn't worry too much about which one you prefer. But if you do see the answer in the multiple choice in terms of pi, like the answers might be 6 pi, 8 pi, 16 pi, then you should use the pi button when you're doing your calculation, because it'll make it much easier to spot the right answer. Okay, let's talk about the formulas. Circumference, which we usually use the letter C for, is the distance around the edge of a circle. The formula is 2 times the number pi times the radius of the circle. Now, the radius of the circle is just half of the width of the circle, like that. If we were talking about the diameter of the circle, that would be the whole width of the circle. There should really be an arrow on the other end of that, but you get the idea. It's the whole, the diameter is the whole width of the circle. The radius is half of the width of the circle. And you'll notice that this formula uses the radius. All right, we'll practice that in a moment, but first let's talk about area. Area is the space inside of the circle. This formula looks kind of similar. It also involves pi, but in this case, we're going to multiply pi times r squared. Once again, we're using the radius. But this formula says we're going to square the radius and then multiply it by pi. And that will give us the space inside of that circle. Sometimes the answers for area or circumference will involve pi. I mentioned that a moment ago. So here we have a circle. It has a radius of 3. We know that's the radius because this arrow shows only half of the width of the circle. So the circumference for this circle would be 2 times pi times our radius, or 2 times pi times 3. And if you use your pi button in the calculator, that's going to give you an answer of 6 pi. And I encourage you to grab your calculator, pause the video right now if you need to, and do that calculation. And you'll notice that you get 6 pi. The pi button is on the left-hand side of your keyboard. Now, if you don't want that answer in terms of pi, you can hit the toggle key on your keyboard just above the enter key, and it will change that answer of 6 pi to about 18.85. Sometimes you will need to do that. A lot of times you will need the decimal answer, but this way you get both answers. Let's move on to the area. The area equals pi times r squared. So that means pi times 3 squared. Your calculator will give you an answer of 9 pi. Then hit the toggle button, and you should get an answer of 28.27, rounded in the decimal form. In this video, we're going to talk about calculating the volume of various 3D shapes. So first of all, a little background on volume. What is volume? It is simply the amount of 3-dimensional space. For example, how much can you fit into a box? How much concrete is it going to take to pour a sidewalk? How many cups of flour to make cookies? And even how much air is in a room is a measurement of volume. Key to volume problems is to practice using the formulas. There are a lot of shapes. We have examples here: spheres, cones, Cubes. This shape here is called a rectangular prism. You might think of it as a box, a pyramid, and a cylinder. And they each have their own unique formula. So it takes practice with each one of these in order to start to get comfortable calculating the volume of those kind of shapes. I'm going to go through 4 of these in this video. So in this case, we have a rectangular prism, a box shape. The formula for that is fortunately the simplest of the volume formulas. It's length times width times height. That's it. You are going to be given most likely 3 numbers in your problem, and you're going to multiply those 3 numbers together, and that will give you the answer. So this is one of the easiest volume problems for you to solve. So here's an example. What is the volume of this shape down below? We look for our 3 numbers. They might not be labeled as length, width, and height, but that doesn't matter. We know that we need 3 dimensions. So we have 3 and 2 and 2, and we're just going to multiply those together. 3 times 2 times 2 equals 12, and there is our answer. Example 2, a cylinder. So we can see that our cylinder has a radius of 2 and a height of 3. The formula for the volume of a cylinder is pi, which you can either use the pi in your calculator or 3.14. Either one should give you the right answer, times the radius squared, and then times the height. So let's take a look at our answers in this case. What is the volume of the shape below? We are simply going to use pi. I would generally recommend you use that in your calculator. The radius is 2. Now here's where you need to be a little bit careful, because sometimes they will give you the diameter, and you're going to have to divide that by 2 before you use it. But in this case, we're given the radius, and then we are going to multiply by our height, which is 3. And just let your calculator do that work. And if you're using the TI-30XS calculator, this is going to give you an answer of initially 12 pi, which is a perfectly good answer. And sometimes the answers for questions like this will be in the form of pi. But if you want a decimal version of that, hit the toggle button, and you should get 37.7. Next shape, a sphere. Here we have a sphere, and it has a radius of 3. Same warning about spheres. Sometimes you might be given the diameter. For instance, for exactly the same sphere, they could have said that this dimension is 6, and it's the same thing, but we want to convert that 6 to a 3 so that we have the radius before we get started. So there's the formula for a sphere. 4/3 times pi times r cubed. What is the approximate volume of the shape shown below? We want to just carefully substitute in. Now, the nice thing about the formula for a sphere is that there is only one value that we need to get from our shape. That's the only important value of a sphere, is the radius. So let's substitute it in. I'd use the fraction function for 4/3 in your calculator, and then multiply that by pi, again using the calculator pi value, and then times 3 to the 3rd power. Now this is where you have to use your other exponent. That's the hat key above the x squared key on the TI-30XS. And we let the calculator do the hard work here, and you should get the number 113. Now you'll notice in this case, we don't get an answer in terms of pi out of the calculator, and that's because it's not like a convenient number. So they will just jump right to the decimal answer, and that will sometimes be the case. We have a cone, and here we can see that our cone has 2 dimensions on it. We have the height of the cone from the bottom to the peak, and we have a radius, I'm going to point out that sometimes you will also be given another dimension, and that would be this slant height here. That's necessary in order to calculate the surface area. But in this case, it's not dimensioned because we don't need it to find the volume. Let's take a look at our volume formula. 1/3 times pi times r squared times h. So you start to see that there's a similarity in these formulas. And this formula is dependent on our radius, r, and the height, h. So we do not need that slant height that I was talking about. What is the approximate volume? With volume and with surface area formulas, the steps are the same. Identify the shape. We need to know that this is a cone so that we can get this formula. We need to know that we're after volume so that we grab the volume formula. And then we find our values and we substitute. In this case, h is equal to 8, and our radius is equal to 6. Same warning about the radius and the diameter. If you're ever given the diameter in a problem like this, convert it to a radius right away. Let's set this up. It's going to be 1/3 times pi times our radius, which is 6, and we're going to square that. And then finally, we're going to multiply by 8. And the number that you should get for that, I strongly encourage you to be practicing these with me, is 301.6. This video, we are going to review the calculation of surface area of 3D shapes. What is surface area? It is the area around the outside, or perhaps sometimes the inside, of a three-dimensional shape. For example, the amount of paper to cover a box, the bare minimum amount of paper to cover all 6 sides. The wall plus floor plus ceiling area of a room. If we're talking about painting all of the surfaces of a room, we'd paint the floor and the ceiling and all of the walls, and that would be the surface area of the room. The outside covering of a volleyball, which would be a sphere shape, and the minimum material to create a closed can, which would be a cylinder. The key to surface area problems is to practice using the formula. There are a bunch of different shapes, and each shape has a unique formula. Surface area formulas tend to be more complicated than volume formulas, so you want to be comfortable finding the values you need in each formula and using them a few times so that you're prepared to do those calculations. Let's take a look at a few examples. Here's our first, a rectangular prism. There's the formula, and we're being asked to find the surface area of that box. Notice this formula, as I said, is a little bit more complicated. 2 times the length times the width plus 2 times the length times the height plus 2 times the width times the height. Why is this formula so complicated? It's because we have sets of similar sides. This is the front, and then back here we have a similar exact size, same size space on the back side of this box. So that's why we calculate that area, multiply it by 2. These ends are the same. This end and this end are exactly the same. So we have 2 of those. And we also have a top and a bottom that are the same size. So that's what's going on in the formula. We're calculating the area of one of them, and then we're multiplying by 2. It is important in a problem like this to label these. So I'm going to call this one length. I'm going to call this one width, and I'm going to call this one height. It's not important which one is which. It's just important that we keep them straight as we plug it into the formula. So 2 times our length, which is 4, times our width, which is 2. Length is 4, width is 2. We move on to the next part. 2 times our length, which is, again, 4, times our height, which is 3. And then we're going to add to that 2 times our width, which is 2, times our height, which is 3. So I hope you can see the importance of that labeling in keeping track of which value goes where. Let your calculator do this work, though. Multiply all of that, add it together, and you should get the answer of 52. Let's move on to the next problem, a cylinder. There's the formula for a cylinder, and you can see that that's a little complicated. We're trying to find the surface area of that shape. We recognize it's a cylinder. We look up this formula for surface area, and then we find the value of the variables that we need. We know that we need the radius and we need the height. Here is our radius. If you are given the diameter, remember to divide that by 2. We always want the radius in formulas like this. So we have our radius and height, and we're ready to go. So 2 times pi, use your pi button in your calculator, times 2 times our height of 3. Then we add the second part, which is 2 times pi times our radius squared, times 2 squared. Let the calculator do that work, and you should get the answer 20 pi. And that may seem like a strange answer to you, but when you use the pi button in the calculator, sometimes you will get the answer in terms of pi. If you want a decimal answer, as we do here, hit that toggle button above the enter key with the 2 arrows, and that will convert this to a decimal, which is about 62.8.